Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.5 curve sketching. Let's begin with fx equal to x to the 3 over x squared minus 1. In order to sketch a curve, we need to get a few information from the curve. Step 1, domain. The domain of a rational function is odd number, except when the denominator is 0. So x squared minus 1 set equal to 0. And so we know that x equal plus or minus 1. So domain is all number except these two. Negative infinity to negative 1, negative 1 to 1, 1 to infinity. Step 2, we want to get all the asymptote. For the vertical asymptote, we can get it by setting the denominator equal to 0. X squared minus 1 equal to 0. So x equal plus or minus 1. Meaning that x equal 1 is a vertical asymptote. X equal negative 1 is another. We have two of them. For the horizontal asymptote, we need to find limit x go to infinity fx, and also limit x go to negative infinity fx. This is a rational function, so we just have to take the quotient of the leading terms in the denominator and in the numerator. So this will be the same as limit x go to infinity x to the 3 over x squared, which is limit x go to infinity x infinity limit x go to negative infinity x3 over x squared. So that be limit x go to negative infinity x, and this is negative infinity. There's no horizontal asymptote, but then we know where the curve should go. One more thing is, because the degree of the numerator is bigger than the degree of the denominator, we got to do the division, because that will give us the slant asymptote. Doing the long division, x squared minus 1 divide into x to the power 3. X squared equal to x to the power 3 x time, and x times x squared is x to the 3, x times minus 1 is minus x. Subtraction, this cancel out. We have x left. So x squared minus 1 cannot go into x, and that is it. What this tells us is the quotient is y equal x, and this is the slant asymptote. It only works for rational function in which the degree of numerator is exactly 1 degree higher than the degree of the denominator. So we have the asymptote and the domain. Now, in order to see the function, we need to figure out where it increased and where it decreased, the local minimum, local maximum. So that will be the step 3. Increasing, decreasing interval and local min max. So to do that, we have to take the derivative. It's the low d high minus high d low. So low is x squared minus 1. D high is derivative of x to the 3 minus high d low over low square. So we have a x squared minus 1 times 3x squared minus x to the 3 times 2x over x squared minus 1 square. And we have a 3x to the 4 minus 2x to the 4 is x to the 4 minus 3x squared over x squared minus 1 square. Now we set it equal to 0. And we say that we have a x to the 4th minus 3x squared equal to 0. So x squared minus 3 equal to 0. X equals 0. And x squared minus 3 equal to 0. So we have x equal to plus or minus root 3. Let's make an interval and do the testing. We have first critical number, negative root 3. Second one, 0. Third one, root 3. However, we have two vertical asymptote, x equal 1 and x equal negative 1. Minus 1, 1. In this case, we have to test out exactly 1, 2, 3, 4, 5, 6 interval. Negative infinity 2, negative root 3. Minus root 3 to negative 1. Negative 1 to 0. 0 to 1. 1 to root 3. And root 3 to infinity. Pick a number and test that. F prime of negative 10. It's more than 0. So fx is increasing. Pick f prime of, let's say, negative 1.1. You see that it's less than 0. So decreasing. F prime of negative 0.5. Also less than 0. Decreasing. F prime of 0.5. Less than 0. Decreasing. F prime of 1.1. Less than 0. Decreasing. F prime of 10. Greater than 0. Increasing. Okay. So be very careful here. From here, you see that the function go from decreasing, increasing to decreasing. So we have a local max at f of negative root 3, which is, if you do the substitution, you get negative 2.6. And the function go from decreasing to increasing. So right here, we'll have a local minimum f of root 3, 2.6. we do not need to figure out the second derivative if we can use the information from the first derivative to sketch. So first thing to do is attempt to do a sketch and see what we can do here. First sketch is gonna be you can do the asymptote. There's two of them. We have a vertical asymptote and a slant asymptote. Next, notice that we have a local minimum at -√3, -2.6. So -√3 somewhere right here, -2.6. Okay, local maximum. And we also have a √3, 2.6. It's the local minimum. From here, we have to sketch the function so that it match up with the asymptote. So it does look like this. And right here. So we took care of two sides of the function. Now it's just the middle. We know that if we do the substitution, f of 0 is 0. So it's going to go through the middle here. And if you look at the interval from -1 to 1, right? Function is decreasing. So it does look like this. Yay! Pretty nice. Sketch by hand. The best way to check the answer is use the technology. You guys can use Desmos and do a sketch with Desmos and see if this is the right one. Let's take a look at Desmos to see what we have. X to the 3 over x squared minus 1. Wow, look at this. It's pretty cool. Ta-da! Awesome. Let's do another one. One more example. Here come B. Fx equal x e to the x. Same thing here. Step 1. Domain. Well, that is the product of two functions, x and e to the x. Domain of x is everywhere. Domain of e to the x is everywhere. So the domain here is all real number. Step 2, asymptote. Since the domain is all real number, there is no vertical asymptote because domain is all real numbers. That means we just have to figure out the horizontal asymptote. Limit x go to infinity, fx, and limit x go to -infinity, fx. Let us limit x go to infinity, x e to the x. do a direct sub, we have infinity times infinity, which is infinity for negative infinity. Now, if we do a direct sub, then we would have a limit x go to infinity, negative infinity times e to the negative infinity. And that is, well, as you can see, negative infinity times 0. An indeterminate product. So we have to write the function as a quotient and figure out the limit. Limit x go to negative infinity. X e to the x is the same as limit x go to negative infinity. X is 1 over x times e to the x. Or there's a much better way to do it, because x go to negative infinity. It would be better to rewrite this as x over e to the negative x. Ta-da! And now do a direct sub. We'll have negative infinity over e to the negative infinity. Well, we have negative infinity over infinity. Yay, an indeterminate quotient. So we apply L'Hopital rule. Limit x go to negative infinity. Derivative of x is 1, derivative of e to negative x, e to the negative x times negative 1. From here, we can do a direct sub. We have 1 over negative e to the negative of negative infinity, which is 1 over infinity, and that is 0. This means y equal to 0 is a horizontal asymptote. Okay, let's move to step 3. We're gonna need to find the increasing, decreasing interval and local min max. F prime x is, well, it's the product of x and e to the x, so use the product rule. E to the x times derivative of x plus x times derivative of e to the x. Ex times 1 plus x times e to the x, which is ex 1 plus x, and we set equal to 0. We say that e to the x is always more than 0. So that means 1 plus x has to be 0. From there, x equal to negative 1. Yay. Only one critical number. Let's do the testing. Negative 1, negative infinity to negative 1, negative 1 to infinity. Pick a test point and do the testing. So f prime of negative 10 here. Well, it would be less than 0. So fx is decreasing. F prime of 0 is more than 0. So fx increasing, meaning that we have a local min at f of negative 1. Negative 1 e to the negative 1, which is negative 1 over e. Let's try to sketch without using the second derivative test. So we know that we have a horizontal asymptote as x approaches negative infinity. And then from the function itself, right? F of 0 is 0. So the function has to go through the point 0, 0. Come. F of 0 is 0 times e to the power 0, which is 0. Also the local minimum. If 1 minus 1 over e is the local minimum. So with this much information, we can sketch it. As x go to negative infinity, we'll have a horizontal asymptote, and the function has to get near the horizontal asymptote. Then it is decreasing until it reaches the local minimum, and then after that it increase, get through the point 0 to 0, and it just keep increasing. Yay! It is the graph. Same thing here. We're gonna check the answer with Desmos. Xe to the x. Ta-da! Look at this. It's local minimum. We go through the point 0, 0. Thank you for watching. I hope you find the content useful. Please like, subscribe to help the channel grow. I'll see you in the next video.